So here we have a problem that deals with the laws of exponents. And the laws of exponents, as I've talked about in other video, are meant to actually really save us time. And we'll talk about what they are, how they work, and a little bit about why they work. In this question, they ask us to circle all equations that are true. If not true, fix the equation and show your work. So this is a pretty open-ended question. We can fix them any way we want. I'm going to take a conventional approach and work with that. So in the first problem, it says 3 squared, I'll write it larger here, 3 squared times 3 to the third equals 3 to the sixth. Alright. Is this true? Well, what I think about is that 3 squared, I'm not going to work it out, I'm just going to represent it. 3 squared is 3 times 3. And we're taking that and multiplying all that by 3 cubed, which is 3 times 3 times 3. What does this equal? Well, I'm not going to figure out the number, but I am going to notice that we have 1, 2, 3, 4, 5 3's, and a fast way of writing that is 3 to the 5th power. So notice we could have just said 3 squared times 3 to the third is just going to be 3 to the 5th, because we can add the exponents, right? Because we're really just adding groups of the bases each time. And in fact, a shortcut is we have some power, some number a to the x times a, another equal base to the y. We'll always get that base to the x plus y. So that's this one right. Oops, that's that one right there. So this one's not true, and we can make it true by changing the exponent here. The next one, let me write it down here. It says 2 to the third times 2 to the 12th equals 2 to the 15th. Is this true? Well, yes, because here we have the same base as 2 and 2. We're multiplying, and when we add those exponents, we do get 2 to the 15. So we'll circle that because it's true. The next one, this one's not true, because it says 3 squared to the 4th power. Does that equal 3 to the 6th? No. Why? Well, this really means you can think of it as in two ways. The first would be, well, 3 to the second to the 4th power. So that means take 3 to the second, whatever it is, and take that to the 4th power. So 3 to the second times 3 to the second times 3 to the second times 3 to the second. 1, 2, 3, 4 times. And here again, we're actually back to our original scenario. We're multiplying the same base over and over again, so we add the exponents, and that gives us 3 to the 8th. And a shortcut here would have been just to multiply the exponents and then get 8. Another way of looking at this problem is to say, well, 3 to the second to the 4th equals 3 to the 4th to the second. I just switch the exponents here, and this does work. And it might be easier to see then that this means take 3 to the 4th and square that. So 3 to the 4th times 3 to the 4th, and what do we do there? We add the exponents, that's 3 to the 8th. And our last problem here is using division, and this is not true. I should not circle that, sorry. And it says 4 to the third divided by 4 to the second equals 4 to the 5th. Well, what's happening here is we have 4 to the third, which is 4 times 4 times 4. Notice I'm not solving it or rewriting it, I'm just expanding it to think about it. And then 4 squared is just 4 times 4. Well, notice these 4's will just divide out and be 1, and all that's left over is 4, or 4 to the 1st power. So here we could have just taken the first exponent and then subtract the second, and that should equal 4 to the 1st. And to look at some order to all this information, when we multiply two bases with different exponents, we add the exponents. So when we divide, when we use the inverse operation, we subtract the exponents. So multiply, same base, add the exponents. Divide by the same base, you subtract the exponents, and in this case right here, an exponent to an exponent, you can multiply the exponents. Alright, hope that helped.